In this video, we're going to talk about endothermic and exothermic reactions. So, in an endothermic reaction, delta H, the enthalpy change, is positive. Heat energy is absorbed by the system. Now, in an exothermic reaction, it's the reverse. In an exothermic reaction, the change in enthalpy is negative and heat energy is released from the systems into the surrounding. Now let's draw a typical potential energy diagram for an endothermic reaction. So it's going to look something like this. So here we have the reactants, the products. On top we have the transition state, also known as the activated complex. Delta H, the enthalpy of the reaction, is the difference between the potential energy of the products and the reactants. So because the products has more energy than the reactants, delta H is positive, and so this reaction is considered to be an endothermic reaction. Consider this one. So notice that the energy of the products is lower than that of the reactants. Therefore, energy was released since the potential energy of the system decreased. So delta H, the enthalpy of this reaction, is negative. So this represents an exothermic reaction. Consider this particular potential energy diagram. So this diagram has multiple steps. Here we have the first transition state. This is the second one. Here we have the reactants, the products, and the intermediate. So in the first step, is it an endothermic reaction or an exothermic reaction? Now the first step involves the reactants changing into intermediates. And notice that it's going up the potential energy diagram. So the first step is an endothermic step. Delta H is positive. Now what about the second step, as we go from intermediates to products? So notice that it's going down the potential energy diagram. So the second step is an exothermic step. Exothermic. I believe I said that wrong. So now what about the reaction overall? Going from reactants to products, we're going down the potential energy diagram, so the overall reaction is still exothermic. So now you know how to analyze a potential energy diagram, and you can tell which steps are endothermic and which ones are exothermic. So now let's talk about phase changes. So when ice melts into liquid water, so we have solid H2O converted into liquid H2O. Is this an endothermic process or an exothermic process? So anytime you have a solid go into a liquid, this is called melting. Now, in order to melt ice, you need to add heat to it. So because the ice needs to absorb heat, delta H is positive, and so therefore this is an endothermic process. Now what about going from a liquid to a gas? Is it endothermic or exothermic? So think of liquid water. If you want to vaporize it into steam, do you need to add heat or do you need to remove heat? Vaporization, the process of converting a liquid into a gas, is always an endothermic process. Delta H is positive. You have to add heat to it to vaporize liquid water into a gas. Now what about going from a gas to a liquid? This is called condensation. And this is an exothermic process. Heat has to be released in order for a gas to condense into a liquid. Now, to understand the process of condensation, let's say if the temperature of the room is 25 degrees Celsius and there's water molecules in the air. Let's say it's a humid environment. And let's say this is a table and you pour cold water in this glass. And let's say there's some ice cubes floating. So let's say the temperature of this cold glass of water is about 0 degrees Celsius. Heat is going to flow from the surroundings into the system. The system is the cold glass water. The surroundings is the air and the water molecules that is in the air. So the surroundings is at a higher temperature than the cold water. Heat flows from hot to cold. So heat is going to flow into the cold glass of water. So eventually the temperature is going to go up as it gains energy. And because the cold glass of water is absorbing heat energy, it's endothermic for the water. Now for the surroundings, it's exothermic because the surroundings are releasing energy. Now the water molecules, which are at 25 degrees Celsius, that's the water molecules in the air, they're going to transfer the heat energy into the glass water. And so as they lose that heat energy, they will condense into a liquid. So whenever you have a gas converted into a liquid, it's an exothermic process. Heat energy is released. So these gaseous water molecules, they're going to release their heat energy to the cold water and they're going to liquefy. You're going to see these droplets of water forming at the side of the container, outside of it. And so that's condensation. You see it happening all the time. Anytime you place a cold cup of water in a humid environment, you're going to see water condense on the outside surface of this glass. What's happening is the gaseous water that's in the air is condensing into a liquid, and as a result, it's releasing heat, thus warming up the water that's at a cold temperature. And so that's condensation, and as you can see, it's an exothermic process. So anytime you go from a solid to a liquid to a gas, it's endothermic. You have to put heat to get that going. So to go from a solid to a gas directly, this is called sublimation, and that is an endothermic process. Now the reverse, going from a gas to a liquid, which is condensation, or from a liquid to a solid, which is known as freezing. In order to do this, you have to remove heat from the system. So therefore, this is an exothermic process. Heat energy has to be released. By the way, going from a gas to a solid, this is called deposition. This too is an exothermic process. Another thing you need to understand is breaking and forming a bond. Whenever you break a bond, that requires energy. That's an endothermic process. You got to put in energy to break a bond. Anytime a bond forms, this is an exothermic process. Energy is released. So let's say if you have a solid. In a solid, the atoms are very close together. And so they have strong bonds. But when you heat a solid, the atoms, they move apart. And so as they move apart, they become more fluid. And so the solid converts or melts into a liquid. And as you continue to heat a liquid, eventually the particles will move apart and they're going to turn into a gas. So as you can see, whenever you add heat, you're breaking bonds. The atoms are moving apart. And so that's an endothermic process. Now the reverse, if you were to remove heat, if you take out heat from a liquid, the atoms will lose their thermal energy and they will get closer and closer together and they're going to form a bond and they're going to turn into a solid. So anytime you break a bond where you move atoms apart, you need to add heat energy to it. That's an endothermic process. And to bring atoms together, you want to remove heat, and that's going to cause the atoms to come together, forming a solid. So let's say if you have a chlorine molecule and it breaks into two chlorine radicals. Is this an endothermic process or an exothermic process? Since we're breaking the chlorine-chlorine bond, this is going to be an endothermic process. So the enthalpy of the reaction is positive. Now if we have two radicals and if they come together to form a bond, that's an exothermic process. Whenever a bond forms, heat energy is released. Now there's some examples of reactions that are very exothermic. One example is the combustion reaction of, let's say, a hydrocarbon. If you burn methane in air, it's going to produce CO2 and water. Most combustion reactions are highly exothermic. They release a lot of heat energy. Sometimes you can dissolve salts in water and they too will release a lot of heat energy. For example, calcium chloride. Let's say if you have a solid chunk of calcium chloride, and let's say if you take a glass stirring rod and there's some water molecules on a glass stirring rod. Once you come in contact with this anhydrous or dry form of calcium chloride, it's going to release a lot of heat. In some cases, it can cause the small amount of water that's on its glass stirring rod to vaporize into steam. The dissolution of calcium chloride, it releases a lot of heat energy, so it's an exothermic reaction. Another example is sodium hydroxide. When sodium hydroxide dissolves in water, it too releases a lot of heat energy. If you pour sodium hydroxide into a cup of water, and if you have a thermometer inside, you'll see the temperature go up. And so a lot of these dissolution reactions are highly exothermic. But there are some that are endothermic. You just got to find them. But that is it for this video. Thanks for watching.